We went through this const keyword or qualifiers before in C and C++ languages. We use the keyword const, right, to make program elements constant. So these program elements in the context of C++ could be a declared variable, a pointer, a function argument, and its return type, a class data members, class member functions, and objects. So let's look at this in the context of pointers since we're on the topic. Let's say if you have these two examples here. The first example illustrates const being in front of the value that this pointer points to, right? So this means that the value that this pointer points to is a constant. Now, if you place constant or this const keyword in front of the pointer, this means that pointer itself is constant, right? These are two different things. One is making sure that in the first example, the value that pointer points to, which is an integer, if you were to later reassign it to another value, regardless whether the value before or k, right, was 5 or not, this means you're reassigning new values to it, okay, to its dereference pointer, right? So dereference pointer means that now you're talking about the value that this pointer points to, which is integer. This is not allowed by way of const integer extras, right? Because this means that the value that the pointer points to is constant. Okay, so the second example, the pointer is a pointer itself is constant. So this means that the pointer cannot be reassigned. Okay, so in many instances, when you have pointer assignment, if the pointer is assigned to another value, so this is assignment, right? This is the assignment part. Then this is going to cause issue at runtime. So you can't do that. So just remember if you in the future if come across a const, just notice what is in after that const declaration. So if the value that comes or the this keyword that comes after the const is a pointer, or in this case the value that the pointer points to, or whether this is a pointer itself, this means two different things. Okay, so just be super careful about the declaration itself. This actually makes C++ pretty confusing. But if you always remember to look after this const and see what's after that, then this should be a problem. So we'll do a quick code demonstration to illustrate this. Let's demonstrate the use of const in reference to pointers. So we talked about this in a lecture. Let's just create an integer variable. Let's just say this is k, and this k has a value of 3. And then the first thing we do is to create a const value where this pointer points to. So this means that we can have something like this, integer, and this is a pointer. So this pointer, let's say, points to the address of k, right? So this means that this pointer itself, which is not constant, but it points to a value that is constant, right? Constant is read only. So let's just try to attempt to change the value of k, right, to something. So the way that you do that is you dereference your pointer and set this is, let's say, 5, right? Let's see if this compiles or not. As expected, because the value that this pointer points to, right, because const is in front of that integer here, this means that this variable k is read-only, so you can't really assign anything to it. So what makes C++ a little confusing is that you can, instead of writing this, you can also have it written like this, integer and const, like this, okay? So you can actually place the const in between this integer and the star here and say this. So this is the same thing as is what I just commented out, same effect. Again, you're talking about modifying the value that this pointer points to, which is not a lot, and this value is constant, right? Okay, so this is one illustration. The other one is that just make our pointer completely constant, right? So this means that the pointer itself cannot be reassigned a value. In this case, let's just say we remove this const, right? This const is now fine, but we want to make the pointer constant. So this is what we're going to do. Let's just say this is a new integer, right? So this is all fine and dandy. We're not changing anything here, right? Okay, let's just say now we want to change ptr to the address of k. Now, This is not allowed because pointer itself is constant, so you can't reassign it to another address, right? So this PTR is already pointing to this newly allocated, dynamically allocated address in heap. So by doing so, changing it to the other address means that you're modifying PTR, and that is not allowed because your PTR is declared as a constant variable. So this is the type of errors that you get at runtime. Okay, that's how we illustrate these type of effects, right? And this could be the source of bugs, and sometimes the developers don't get careful with this. You can run into issues, but fortunately, these are runtime issues, which means you can't even compile and run your code without fixing this.